Everyone, today we're going to be talking about linear functions. So, where are linear functions found? Linear functions can be found in many places, including the business, the science, financing, and the robotics, including much more. I won't read all of these for the value of time, but feel free to take a screenshot and read all of these. So, what is a linear function? Linear function is a type of math equation that helps us draw straight lines on a graph. The equation for a linear function looks like this. F of x is equal to mx plus b, but you can also write it as y is equal to mx plus b. So here is an example of a graph for a linear function, and you have the y, the x as the side to side, and the y as the up to down. So you might be wondering, what is this m and b for? So the m number is called the slope, and it tells us how steep the line is. A bigger slope means the line goes up or down more quickly. A smaller slope means the line is more flat. What is the b? B number is called the y-intercept, and it tells us where the line crosses the y-axis. The y-axis is what is the up and down line on the graph, and the x-axis is the side-to-side line. So the y-intercept is a number that tells us how high or low the line starts on the y-axis. So here's a graph. We're going to go through a few examples. So first, if m is 1, so this is the normal graph, it's going to look like this. Just a line going like this. Now, what if m is 2? If you remember, the line will be more steep the bigger m is. So you can imagine the line being like this. The y value will increase faster. Now, what if m is 0.5? Well, actually, that's less than 1. So the line will be more flat, less steep. So it will look like this. Now, same beginning example. What if m is negative 1? You can think of it as a mirror in the center. It will mirror the graph. So it will look like this. Now, what if we change b to plus 3? It will actually be the y-intercept. So the y-intercept will move 1, 2, 3 up. So you can see it touches the graph 3 above. Now, what if it's negative 1? You would probably guess that it's 3 below, and you would be correct. So 1, 2, 3, it moves 3 below. Now, how these old applications work now. So you can take a screenshot and read this, but we're going to be focusing on the business part. So imagine you have a lemonade stand. The lemons it's $2 for one lemonade. It costs 0.5 for each cup made, and the stand itself is $20. So we'll be using this equation. Y will represent the money made, X will represent the cups sold, B will be negative 20 because that's the initial value. So you'll start at a loss of negative. The Y will start at the money made will be negative 20 at the beginning, and M will be the profits per cup. But remember, you lose 0.5 per cup, so you can't just make it $2. You gotta make it 2 minus 0.5, making M equal to 1.5. Now, you want to solve for when he finally breaks even, when he has zero money. He's not in the negatives anymore. So you make it y is equal to 1.5x times minus 20. So y will become 0, and because that's the initial value, and 1.5x minus 20. After doing a few algebra, you're going to transpose 20 to the other side and divide both sides of it by 1.5, which will give you x is equal to 14. So as you can see from this graph right over here, what will happen is you start at negative 20. Your profit is negative 20 at the beginning. And the more cups you sell, the more profit you make. So when the y is 0, you will have sold 14 cups. So it takes you 14 cups just to break even. And you can use this to figure out more things in the future. Now, what if you're looking for $10? When do I make $10? Well, you can see the $10 here, when y is 10, and then you just gotta turn and then see the intercept, then go down, and here you have negative 20. It'll take you 20 cups to make a profit of $10. So, I want to show you this quick example for robotics.
90 degrees exactly.
Okay. We also use linear functions in robotics. So we use it to make perfect turns. So what's the problem? The problem is robots are inconsistent with their turns. So how can we try to make it more accurate? Let's make the robot decelerate when it's about to complete a turn. If you know how turning works for us humans, we don't turn at a constant rate because that is way too inaccurate. So you want to decelerate while you're slowing down to have a more accurate turn. So we want the robot to start at a speed of 100%, and meaning the more it turns, the speed will decrease until it's 0. So x will be the decreased turn, y will be the speed, v will be the initial speed, and m will be the speed decreased. So you can see that we graph it over here. It will start at a speed of 100 and end at a speed of 0 when it reaches an x value or degrees turn of 90. We need to solve for the slope. X is the degrees turned, y is the speed, v is the initial speed, and m is the speed decreased. So if we want the same problem, we're going to have to make when x is 90, when the degrees turn is 90, we want the speed to be 0, so y will be 0, and b will be 100 because that's the speed start, that's the initial speed we want. Now m is something we're going to have to solve for. There are 3 ways to solve for this, we're going to go through all of them. Now first is the normal way of y is equal to mx plus b. We just do some algebra and we'll get negative 10 over 9 equal m. So we can also use this formula, y minus b over x. So what happens here is you put all the numbers, you do some algebra, you do some math, and you'll have the same value. Now the last way is especially given when you're given a graph. Now, given a graph, we bring 2 points. It can be any of the 2 points of the graph. This part is rise over run. So y2 minus y1 divided by x2 minus x1. We have 2 coordinates of the graph. So we'll be using these 2 coordinates and inputting all the numbers into the parts. You're going to get negative 10 over 9. I don't know why it says y there, it should say n. So application. Here's some code we wrote for robotics. X is equal to 90 and y is equal to 0. It calls that at the beginning. Now, end speed would be b. Now here, it's actually using what we learned as our second way to solve for m, y minus b over x. Now, it keeps changing the speed relative to the angle. It gets the angle from the robot and it changes the speed relative to the angle using our formula y is equal to mx plus b.
Today we learned about linear functions and how they help us draw straight lines on graphs. So you can represent this by y is equal to mx plus b, m is the slope, and b is the y-intercept. The slope tells us how steep the line is, while the y-intercept tells us where the line crosses in the y-axis. Linear functions can be used in various fields such as business, science, finance, and robotics. In business, linear functions can be used to calculate profits and break-even points. In robotics, linear functions can be used to make more accurate turns. Now I'd like to acknowledge my math teacher, Sir Chavez, for being an amazing math teacher.
Now I would like to thank your artist courses.